Hello, everyone. I hope you're doing well. Let me find the React scene. There we go. Uh, it's been a little bit since I had a puzzle on CTC, we get to watch Simon solve this puzzle, Frankenstein. I'll talk a little bit about its origin as we get through it, but let's get right off to it. But yeah, this popped up right away because I posted this on Tuesday on LMD and it popped up on Wednesday.
Hello
I think.
And welcome to Wednesday's edition of Cracking the Cryptic.
He agrees
and
it was Wednesday.
An old friend to the channel today. I haven't done a zetamath puzzle in what feels like months, but zetamath has just released a puzzle. Actually, it's got 5 stars out of 5 for difficulty. It's called Frankenstein.
Interesting. It was at 5 stars on LMD for a moment,
which
must have been the moment that Simon looked at it. And there's a few comments to this effect if you look at the page. And then it bounced back to 4. So it has been between 4 and 5, which is, I guess, what I thought was probably going to happen.
Looking forward to getting reacquainted with somebody I admire very much. So this one is, I think it's zipper lines, which are going to be the purple ones, aren't they? And then what is referred to in the instructions as the darker off-green, kind of unpleasant-looking lines are modular lines. So that's these. Anyway, we'll talk about what all this means in a moment. I don't think there's any other jiggery-pokery apart from that. And I'm very much looking forward to having a go at this one. But before we start, I'm going to mention a couple of things. I think there have been 2 puzzles on the channel in just the last
Isabella.
week, which I sort of consider generational puzzles that will live long in the memory of any Sudoku solver who has had the pleasure of meeting them. One of them is yesterday's puzzle, Michael Lefkowitz's The Wall, themed on Pink Floyd.
This is
an astonishing thing. It took me a long time to solve it. I'm not claiming remotely it's an easy puzzle. I didn't find it easy at all, but I do think it is magnificent. So have a look at that if you haven't had a chance to look at it. And the other one is this 4x4, which I described in the title of the video as the best 4x4 in the history of Sudoku. This is themed on the sort of viral logic problem, Cheryl's birthday. And I thought this was just fantastic. Again, not an easy puzzle. Probably.
Sorry for mispronouncing your name, Velzita, in the intro to Killer Cage's video. But thank you for the puzzle.
If you have any spare puzzling time,
I'm glad you enjoyed it, David.
Think you'll get a kick out of them. Now, speaking about spare puzzling time, let me tell you about some other things that are going on. We have scheduled a new stream
Tristan
of
claims
blueprints. So if you've been waiting for a while, we have had a lot of emails saying, where is the next blueprint stream? I'm sorry, but we are doing it on
Blueprints
Monday.
is pretty
Monday
great, I have to say.
UK time. We'd love
I was
to have your
skeptical
company.
at first. I've definitely gotten more
we'll see
into
how we
it.
get on visiting that mad mansion.
If you've not seen, I have been posting a Let's Play of Blueprints.
Other than that, over on Patreon, we've got this fantastic Sudoku hunt by Itrio, Yin Yang Journey. And
I would say David says it's been a long time since I had a puzzle with only 2 kinds of lines. I would say the most common numbers of constraints in my puzzles are 2 and infinity. Usually, I've got a fairly large number where it is 2. Like, I mean, I think my most recent Sudoku before this was just Renbon and Black Dots, wasn't it? I think.
We were nearly up to 2,000 solves for the first puzzle yesterday, and 403 had...
Oh, I said it with an S, and Tristan corrected me and said, no, it's a Z. So I think Tristan actually tricked me, because I think I did say it right in the video then. I think I said it with an S, and then I think Tristan said, no, you should say it with a Z.
Now, it's only crept up a bit for the first puzzle. What did I say? Did I say 403? 431 now for the final puzzle. That's fantastic work. Really well done to everybody who's managed to get through the whole thing. The
Juggler or Marty Sears, I think, are the 2 who really do a lot of that, David.
It would be a good use of your puzzle time. And the prize, which, the competition closes on the 20th, and the prize will be the chance.
Sometimes Paul Fly. I think Paul Fly is the one who did the avocado duck puzzle.
And Sophie, I'm going to meet Sophie this evening. Sophie, I think, is in New Zealand, and we're going to. Sophie won last month's competition, and we're
Simon
going to
going to
try
go
and
to
make
New
a video
Zealand.
that'll hopefully, if we can get through the puzzle, appear on the channel in the coming days. So I'm looking forward to that. And then what else? Oh, our Sudoku worms. Do check these out. This is our new. We've got a new couple of apps. We're launching a whole series of apps which are going to show.
I don't think I'm saying anything confidential to say. I made a worm for them and they liked it, but there was some sort of technical issue. So I'm not sure if you'll get to see the worm that I made for them or not. Maybe I'll make another one. I don't know. Uh, but we shall see. But it was fun to make these. Although I will say, for my personal opinion, I think they're more fun if the puzzles are related rather than just sort of a sequence of 6x6s with 4 givens. Is
Showcase
my
the puzzles of
general
particular constructors.
preference.
This one actually is by Michael Lefkowitz, Juggler, but hasn't come out yet. But we have released Marty Sears, one of these, and also James Sinclair's. So do have a look at those. They're $1 each, and that's tremendous stuff. And I've got no birthdays to do today. It's so weird. Sometimes,
Yeah,
birthdays.
if they don't
I've got
end up
like
using
10
it, I'll
to
publish
do,
it somewhere,
and other days
David.
I've got 0, and today is a 0 birthday day. I hope I haven't forgotten anybody who has written in. Apologies if I did, but in my diary today it was blank. So instead, I'm going to turn my attention to doing some solving. Let's have a look at Frankenstein. I don't really get why it's called Frank. Is it just called Frankenstein because all the lines are higgledy-piggledy?
So I called it Frankenstein for 2 reasons. One of which is that it looks kind of like a guy standing over a table, which had a like Dr. Frankenstein vibe to it. That certainly wasn't intentional, but it sort of had that vague idea. But also, I liked that it evoked the fact that I took 2 constraints that I usually do not rate particularly highly and used both of them. So I considered it a sort of unholy amalgamation, and I thought Frankenstein worked well with that as well. So that is why I went with Frankenstein.
Was quite, was sort of a bit from here and a bit from there all stitched together, wasn't it? So maybe that's why it's called Frankenstein. But the rules are as follows. We've got normal Sudoku rules applying. So we've got to put the digits 1 to 9 once each in every row, every column, and every 3x3 box. The lavender lines are zipper lines. Each pair of digits equidistant from the center digit has a sum. Oh, sorry, there's a lot of airplane noise. Maverick's going mad.
Earth Computer says, surprised I didn't put the break-in box 1 or 5. To me, the break-in is in box 1. It's this digit. But I will admit that sort of like you, from that digit, immediately look over here. And I did worry when I put this zipper in at sort of the very end, as you note, that it might look like this had something to do with the early part. Yeah, I guess for me, it's sort of like this digit and how they bounce around. But if you look at like the very first clue I put in the grid, so I might as well say now that the first constraint that I decided to use for this puzzle was entropic lines. And so the very first thing I did was draw in an entropic line that had exactly this shape. Then I was like, okay, well, what do I do with it? And the reason I wanted this shape is because I think it's cute that this digit on an entropic line can't repeat here or here or here or here. And so this digit has to appear in one of these 2 spots in box 2, whatever it is, with an entropic line here. And then I was like, what do I do with that? And I was like, okay, well, I probably want to do some sort of like mathy thing to like add the digits or something. So then I added region sum lines. And so for a while, this was an entropic region sum line puzzle. But it turned out that really the 2 digits I wanted to add were those 2, because those 2 were the 2 places that this digit could go. And so I like dug through my brain for like what constraints I could possibly find. And the reason I used zippers was because it combined those 2 cells. And then after sort of playing with that a little bit, I realized that actually entropic lines with addition, they're related, but they're messy to try and talk about what the relation is. Like if you add 2 middle digits, you get a high digit, but if you add 2 low digits, you maybe get a low, maybe get a middle. that kind of thing. So then I ultimately shifted from uh, entropic to modular, and that is sort of the roundabout story with how this puzzle ended up using two different constraints that I don't often use, by which I mean I think I have had approximately three modular lines in all of my puzzles. Uh, uh,
Out there at the moment.
yeah,
What is
Earth
he doing?
Computer is sort of like saying like my sort of vision of how the break-in would be is to do this, do it with this digit, and then do the same thing with this digit, and look how those two interact. So I guess for me, those are sort of like parallel steps. But the sort of the fact that this is very clearly mirrored in structure, I was hoping would telegraph loudly enough to look at these cells. But I will say, actually, I think it was not loud enough because I've and this is not very common for me, but I've gotten several comments from people saying they spent an hour looking for the break-in. Uh, when I never try and make it too secret what people are looking for, but I think here there's enough distracting stuff, like the fact that every cell in box 5 has a thing on it, every cell in row 6 has a thing on it. There's enough distracting stuff that one might be inclined to look at that I think I maybe hid slightly too much what the break-in was, which wasn't my intention. But I think it was maybe not quite loud enough.
Has a sum equal to the central digit. For example, 16827 would be a valid fill for a zipper line, because let's try and find one. 16827. Let's do that one. 16827.
Simon.
So the middle digit is. Oh, I've done it on the modular line. I'm so sorry. Let's change that. Oh dear, that's not a good start, is it? 16827. Right, so this digit is the.
So now, completely by accident, I think it turns out that this is exactly what we. I think this is exactly what this zipper line turns out to be. I might be wrong, but I think that's true.
Of the zipper,
but
which
not
is the
for any
lavender
reason.
line.
It wasn't like
And
a
then
attempt
the digits
at
that
a
are equidistant from the
mind
centres.
game.
You can see these two are both the same distance away. You add those up and you get 8. You add these up, you get 8. So that's why. That's how a zipper works. And then it says the darker off-green kind of unpleasant looking lines are modular lines. Each set of 3 adjacent digits along a modular line must contain one of one.
Henry Pye James, by the way, conjectured that I made the lines the color of Simon's sweater that Simon often wears in order to insult Simon's sweater green. Rather, it's just that I just really don't like the default color for modular lines, and it's basically because they took the good green for zippers, or sorry, for whispers, German whispers. And so if you want to make another green color that's distinct from it, you have to pick something that's like jarring to look at. Although there's a little bit of variety in exactly what hue people use for modular lines, but it's generally a pretty messy one. So it wasn't an attempted dig. I like Simon's sweater green. We have a color on the channel that we use for it all the time. But anyway, we'll see. Henry Pye James also, I had to convince him that the intended solve path wasn't to bifurcate at one point. So we'll see if Simon navigates through that.
And 1 of 369. So
MicroStudy made some rainbow lines
here. If this was a 147 digit, then this could be 369. But if that was the case, this one would have to be from 258. So that along the line there's one of each in every. And if this line continued, say it went from here to here, then look at those 3 digits would have to include a 258 digit. So this would be a 258. That's all the rules.
There was a long period in setting this where this modular line, and we'll talk about this modular line, whether Simon uses it or integrally or not. But in fact, actually, for like really the majority of the logic, you only need this to be a 2-cell modular line. Oh, sorry, you can't see my cursor.
Do you have a go?
For some reason. There you go. Now you can see it. This could have been a 2-cell modular line. But the annoying thing about modular lines is that if you want to include any 2-cell modular lines in your puzzle, you are obligated to include a separate sentence in the rules explaining what a 2-cell modular line means. Uh, and that annoyed me immensely. So I looked for an excuse to extend the line by one. And even though I think this admittedly looks kind of hideous, the way that this line extends sort of into this line's business, but not in a way that sort of flows with the curves. Like, I'm okay with this, like, one-y line going onto the table or whatever. This, I think, looks kind of horrendous, but it spared me having to write an extra line in the rules to explain what a two-cell modular line means, even though I think almost everyone would correctly intuit what a two-cell modular line would mean, but I would bet I would get 20 LMD comments complaining that it didn't say what a two-cell modular line meant. And anyway, it turned out to be the case that there was no way this line extending into this cell would work. So basically, I was doomed by the point I put it down. The way to play
is to click the link under the video
as
usual. But now
that's the story of the slightly ugly line.
Let's get cracking. I will download all of the secrets I know about both of these types of lines in a mere scintilla. I know very, very few secrets. Zipper lines, if you want to put... Well, no, that doesn't work. If you want to put... a 9 on a zipper line, it will have to go in the middle cell. Because obviously if you put 9 along the line, you're adding a digit to 9 in order to get to the middle cell, and that's not going to work.
I did want, by the way, to mention, Isabella said that she often confuses zipper lines and arrows, which I do all the time. I have no idea how I did not screw it up in setting this puzzle. Surprisingly to me, zipper lines were not included in Sudoku Maker, so I had to do them as aesthetic lines, and I was terrified. I checked the final grid like 5 times to make sure that all my zipper lines actually added these 2 cells and these 2 cells instead of the other, because I was sure it was going to turn out that I had at least once treated a zipper as an arrow instead of as a zipper. Also, at numerous times during the setting process, I will tell you this modular line I treated as though it was a zipper for some reason. I don't know, this one in particular. And then I had to back up and be like, no, you can't use the fact that this thing, that this digit isn't a 9 because it's on a zipper, because it's not a zipper.
There are mathematical properties of zipper lines that can be interesting. I'm not seeing anything very good immediately here. Oh, or am I? For example, those 5 digits there, we know sum to a multiple of 3. Very straightforwardly, if this central...
Funnily enough, this is a step I tried so hard to put in this puzzle. It was like very often the case is to note that, yes, a length 5 zipper sums to a multiple of 3, and a 3-cell modular line sums to a multiple of 3. And so I tried repeatedly to put in a spot where you'd have a 5-cell zipper, a 3-cell modular line, and 1 cell left over in the row. And you could make exactly the observation that Simon is making to say, okay, so the last cell in the row is a multiple of 3. And that would be really clever in terms of like being useful for modular lines and these sorts of things. And just every time I tried to put it in, it just never stuck. So Simon is making an observation here, which is completely reading my mind about the kind of step that zetamath is going to try and put in this puzzle. Zetamath just did not succeed in putting this step into the puzzle, despite his best efforts.
Central digit is x. Let's make it x. Obviously, these 2 sum to x, and these 2 sum to x. So the sum of the line is 3x, which is obviously going to be a multiple of 3. So sometimes that can matter, you know, because, I mean, by a secret I share with only my very favourite people, a complete column of a Sudoku is also going to be a multiple of 3 because it's going to sum to 45. And that's what the digits 1 to 9 sum to. That's something I share with only my very favourite people, by the way. So what we effectively know then is that those 4 digits sum to a multiple of 3, because if that's a multiple of 3 and the whole column's a multiple of 3, then the difference must also be a multiple of 3. But a shorter line like this I mean, I think that just sums to 2x. I don't think there's anything more x here and then another x in the wings. So that one's going to sum to 3x, but that's not even all in the same row.
This line was in row 6 for forever while I was setting. One convenient thing about the fact that Simon did this puzzle right away is that I set this puzzle on Monday, so I actually remember what setting this puzzle was like. Maybe started on Sunday and finished on Monday or something like that. But this line, I just kept rewinding. Like I had like these two lines, this vertical line and this line running horizontally, this line over here or something like that. Just those 5 or 4 lines for forever. And I was like, what on earth do I do? I cannot figure it out. And what finally ended up sort of letting me make everything work the way I wanted was noticing that this line worked much better than the horizontal one in terms of letting me use Sudoku in the way that I wanted to be able to use Sudoku to relate things to this cell, as you'll see.
No. Okay, so this is... I don't think this is a mathematical break-in. It's going to be something to do... Well, if I was guessing, I'd say it's either going to be that cross there, this sort of Angel of the North type statue here, or this sort of Frankenstein's head part of it there.
Yes, Simon has not learned the zetamath meta that you should always look at box 1.
Well, that digit's not on its own zipper, which is...
It's funny, by the way, if you've been following zetamath puzzles for a really long time, like if you go back to the 3rd puzzle I had on CTC, Ambiguity, I had a whole lot of puzzles where I had this sort of shape wrapped around box 5. And there was the whole thing about like where these digits end up in that box. In that case, it was like thermos and arrows wrapped in this particular shape. But it was sort of amusing to me that I recreated that completely by accident here, because I really was intending to only originally use like this kind of constraint or whatever, and then eventually sort of like how do I advance this step? Well, mirror it is usually a good thing to try if you have nothing else to try, and so I ended up doing it. Of course, like back in the day, you couldn't have done this because you couldn't have had 2 lines that ended in the same cell, but now thanks to Sudoku Maker, you can make this look a little bit more
pristine. Is that mattering or not? I mean, okay, maybe one thing we could do is, and I suppose this is a bit of a secret. I mean, I hinted at it in the instructions, but every 3 digits on a modular line has to contain one of each modularity. So one of each type of digit. So the 1, 4, 7s are all, if you divide 1, 4, and 7 or by 3, you always get a remainder of 1. If you get 2, 5, and 8, you always get a remainder of 2. And if you divide 3, 6, and 9 by 3, you always get a remainder of 0. So that's why they're called modular lines. But that one is going to be the same modularity as that one, isn't it? These two are the same. Because those two are going to be something, but that stretch of 3 needs a yellow one, and this stretch of 3 needs a yellow one. So those are going to be the same, these are going to be the same, and that one's going to be something else entirely. And that one is going to be either blue or yellow modularity then. Because this digit, let's say that was a 6, we can ask the question, where does that Sudoku digit go in box 2? And where it can't go is on its own tuning fork. Because if that's 6 and you put 6 there, this would have to be a 0 in order to make 6 plus 0 equals 6. So this digit is going to go in exactly one of 2 places.
This was a question when I was first setting this, is like, do I want this to be a puzzle where you color digits and like do what I usually call like ketchuping or whatever? which was how I originally was describing it when I just had the fork thing of like this digit goes in one of these two places, this digit goes in one of these two places. But would be very awkward if this were a puzzle with modular lines where you colored digits. So I tried to make it so that you could color the modularities and still sort of keep track of the digits, but not have to have two different layers of coloring. That it would be pretty clear, hopefully, what was going on with that, without having to go too crazy with it.
Now, I don't know what that means yet. The red one is going to have to go in one of. Oh, is that wrong? No, that's true. Yeah, the red one is going to have to go in one of those two places actually, because it can't repeat on its own modular line, because it could only repeat in the third position, if you like, and it only so. So red is also in one of those positions. So, yeah, okay, so maybe it is a little bit mathematical then. Yeah, maybe it is. Okay, so what that's telling us is this. Okay. We know that this digit has some. Actually, maybe I'm going to change the colouring.
I would definitely
Let's
reverse the
just make
coloring
that
here.
yellow. And I'll make these ambiguous, I think. I'm not sure if, but I want to just.
I definitely agree. By the way, David in chat said that Simon is very good at reading what sorts of step setters he's used to enjoy. Absolutely. I'd say like I feel like in 95% of puzzles of mine that Simon solves, it feels like he's reading my mind.
Be clear that I'm talking about this one. So this one has some sort of modularity, which is yellow. Yellow modularity. Now we know that yellow belongs in one of these two positions on the other, but just by Sudoku in this box. But we also know from the colouring we just did, that this one and this one are yellow modularity plus blue modularity. And that's very interesting, because don't joke about me. The jokes have all been made before, many times by members of my own family. But things I find interesting. So if you have a digit with yellow modularity, say it was 1, 4, or 7, and you're adding it to a digit
Welcome,
with
Stephanie.
different modularity than 1, 4, and 7, to arrive at a digit that has the same modularity as 1, 4, and 7, what do we know about the modularity of the digit we're adding? It must be a 369 modularity, mustn't it? It must be. So, for example, if this digit was 7, we know one of these is going to be a 1 or a 4 because it has the same modularity. The other one will have blue modularity, and we're going to be adding 3 or 6 to that in order to get to this 7 digit. So blue modularity is 369, and blue modularity is either in those two or it's in those two.
It is incredibly annoying at this step that you learn what modularity blue is, and you don't for a long time have anywhere in the grid to mark that blue is 369. You just have to like recall that blue is 369, but I didn't really have any good way to fix that, sadly. And yeah, Isabella, I remarked earlier, I did have these as entropic lines for a while when I was setting it. It just didn't quite work out as nicely, which is why they ended up being modular lines. But I would never have started a puzzle with let me make a modular lines puzzle. It just sort of ended up that way because of that. But yeah, I agree that entropic lines are much more intuitive.
So, right. Is this true? I think this is true. So I think, weirdly, the red, I think this might have to be double red. Let me just think about that. I think that's right, isn't it? Well, because what we're saying here is that we know that red's modularity is not 369.
Ooh, David has given out some memberships. Let's see who got the memberships. Stephanie, Thomas, David, a different David, Tenadian, and Anders have gotten memberships. So welcome. Enjoy your memberships. Let's get you a donation dance. As part of your memberships, you can use these Zach icons, by the way. But Zach is our digit dancing penguin. Boop, 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 woohoo! Boop, 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 woohoo! Boop, 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 woohoo! Thank you, Zach, and thank you, David. Huge appreciation there. Greatly appreciated.
So it's either 147 or 258. And we're summing. So if this was 147 and red was 258, what do you have to add to 258 modularity to get 147 modularity? Well, it's another 258 modularity because you've got a 2 remainder digit and you've got to add another 2 remainder digit, i.e. what the remainder is when divided by 3, in order to arrive at a 1 remainder digit. And you can see that. So if we add, if we add 2 and 5 together, you would get 7, for example. And if on the other hand, this was a 258 modularity digit, then we know that red is 147, and what you add to 147 modularity to get a 258 modularity digit, that's going to be another 147. So this is double red.
Yeah, I was very unsure how intuitive or not intuitive this step would be to non-mathematicians. I would say something like, in my brain, this is using something crazy like an automorphism of a cyclic group of order 3 or something in order to say that this is definitely true. It seems like it was split how intuitive it was, because like I said, some people commented that this break-in was very difficult for them to find. Some people, I think, found it fairly quickly, but that was a step of sort of understanding that and finding that to be an intuitive, reasonable step. I think probably depends a lot on how much you've thought about Mod 3 universes.
I'm not actually sure what this is doing. Is that doing something here? Yes. Yes, it is. Because I've now remembered that modular lines are the unpleasant lines, aren't they? So that's red modular. That's beautiful. That's ridiculous. Right, that is absolutely beautiful. So the idea is because you can prove that this is double red on the top tuning fork.
Oh yes, as David says, please like both this stream and the original
video. It's going to work
video.
from a modular perspective. So whatever the modularity of this is, it's going to be mimicked there. So clearly they can't both be red, can they? Because that would mean there would be 4 reds in the column of the Sudoku. But there's only 3 of any modularity. Now what would happen if this was red? Well, then that would be red. And that would be 4 reds again. So that's red.
So just as some people ask, and if you've not set puzzles before, you might be wondering, like, how on earth does someone set something like this? And so I think this is an excellent point to sort of think about how this is made, because I started with, okay, I got this one line and I know that this digit's going to be over in one of these two, and I kind of want to repeat that over here. And so, like, I don't know, an hour into setting this, I'm looking at a grid that literally has these 2 lines and nothing else in it. But what I noticed from that is that you actually, once you choose these 2 types of lines instead of every other permutation of types of lines I tried to choose, is that these 2 have the same color. So just what Simon noticed, it only depended on these 2 clues. And then the question is, well, what do you do with that? And so then then you can add the next clue. And so, as Simon notes, the next clue to look at is this length 5 modular line. That was the next clue I added because it's like, okay, well, if I know these two are the same color, the way to reward that with a modular line is to make a length 5 modular line. I mean, there's probably other ways, but that was the way I thought of at the time. And then, so what do you do there? Well, then you want to somehow use the fact that this is red in some useful manner. And so I drew a big zipper through it. Now, originally, the zipper I drew through it went horizontally through it. And that, as I alluded to before, was kind of a disaster because it made it impossible to do anything. But basically, that's sort of how you put this together, sort of like one clue at a time, looking at, okay, what are the deductions I want someone to make, and how do I then draw in a clue that uses that deduction? So sort of if you're trying to figure out, like, how would you make this, that's exactly how you make this, is to sort of piece this together, sort of like one step at a time by adding one clue that uses the thing you wanted.
So this digit is either... well, if you don't mind, I'm going to be frivolous. I'm going to put everything in, and now I'm going to. I can do much better than that, because this is not only red modularity, but it is the central digit of this zipper. Now, the minimum those digits would be 1, 2, 3, and 4, which means this digit is at least a 5 because we're adding at least a 4 on its line. So that is not 1, 2.
Oh, that's a much better way than to notice that this is at least a 5. Than my way that I do this every time is to say 1, 2, 3, 4 sums to 10, but that's twice this digit, so this digit's at least 5. Simon's one of these digits is at least 4, so this number is at least 5 is way better.
7 or 8. Now, now it might get more complicated. So, sorry, I've got nothing now. I'm sure there's more trickery is available. Is it something to do with this row?
So I can tell you what my brain focused on at this point in this setting process, which was that this cell is 578, and if Simon makes the same deduction, this cell is 578. And so the thing I really tried to sort of harp on was, okay, so one of them has to be 7. There's no way you get around one of them being 7. I'm not sure how much Simon is going to latch onto or use that. It is, I think, useful to notice, but I don't think you have to notice it. I'm not sure. I think you could probably get through this without ever noticing that. But that was the thing my brain sort of liked was, oh, there's only one thing on here that's of the 147 flavor. So I really tried. And so like the reason why I sort of bent this line in here or whatever is like this cell, at least that digit can't be 7. I tried to use.
Okay. This is not 5, I'm going to claim. Because if red is 258 modularity and this is 5, those two digits are 2 and 8, adding up to that digit, which would be a 10, which is perfect in terms of yellow modularity, because it would be a one remainder digit, but 10 is not a Sudoku digit, so it's imperfect from that perspective. So this is 7 or 8, and these digits are either 1 and 4, if this is 7, or 2 and 5, if this is 8, and this digit is 5 or 7. That's really weird. That's really weird.
It is very weird.
I thought this would be bigger than that. So if this is 5, this is a 1, 2, 3, 4 quadruple. Oh, that would work, wouldn't it? Because we'd need a 369 remainder digit for the blue digit that's in one of those two cells, and it would be the digit 3. So it'd be 3, 2, 1, 4, 7. Oh no, but then that should... Hang on.
I think both universes work here for quite a
No,
while.
hang on. Am I going mad? No. 3, 2, 1, 4, 5 is what it would be. And 5 is yellow modularity. Well, and that would be 7. Okay, so that's okay, because 7 and 5 are different modularity.
I didn't actually have a computer solver, so I can't be
So
certain
1,
that it
2,
wasn't
3,
resolved earlier.
4. This would be 2, 3. This would be 1, 4. I'm sorry, I'm stuck again now.
He's looking at the right cell.
What are you up to, zetamath? What am I meant to do? I think probably this was correct, what I've done here. Like, as a starting position, because getting that as double red is so beautiful with this line. That's classic zetamath stuff, that is. I'm worried I'm meant to see something obvious off the back of that. I mean, what are we going to have? We're going to have 2 yellows and 2 blues down there.
It's not incredibly helpful,
just
sadly.
put yellows and blues. And if that's blue, say, that will be blue. And if that's yellow, that will be yellow. And then this is going to be yellow or blue. And whatever that is, this will be the opposite.
You know what the most cursed idea I've ever had for Sudoku pad was? So if you've seen in math, sometimes you write plus minus in front of something if you don't know if it's the plus one or the minus one. And a lot of times in math, you need a way to denote, okay, this is also plus or minus, but it's not the same plus or minus, it's the other plus or minus. And so the way mathematicians write that is they have a plus with a minus under it and a plus with a minus over it. As the 2 ways of denoting that for the one plus minus and the other plus minus. And it has occurred to me at times to suggest to Sven, well, if you could make this a yellow-blue and a blue-yellow, you could actually distinguish the yellow-blue and the blue-yellow in here by doing that, which is, I think, from every possible point of view, like the worst idea on earth. But it occurs to me probably about once a month that one could do that.
But then that on that modular line will be the same. We know that's not... I think it might be this row. That's where my... I'll tell you exactly what my brain is saying. My brain is saying it's that row, but it feels very complicated and I don't want you to think about it. So it's a bit
that is exactly how my brain tends to think about these things. The thing that he could do with just combining words that he's already said is that this digit goes in one of these 2, so therefore this is a 1, 2, 4, or 5. That was the... that is what I sort of intend. And that'll make his looking at this row that looks complicated that he doesn't want to think about, it'll make it a little better.
What we talked about yesterday on the channel, sometimes you have to force your brain to think about things. Your brain will always try and be naughty.
Sorry if that was flickering horribly.
But... how do we do this then? Oh no, I don't know. So if we know this is another of these length 5 modular lines, so it's going to have two of one modularity, or it's going to have a pair of 2 different modularities, and then
welcome, Isaiah.
This digit is going to be sort of the leftover modularity, isn't it?
Does Simon have a trolley going by his house? I don't think I've ever heard the trolley before, if that's what it was.
Okay, and there must be one of each modularity on this. I was just thinking about this line. Obviously, we've got a situation where, again, x here is the sum of those two. So what you could have...
I'm sorry your brain is
digit was
having
9,
difficulty, but I'm glad you have
had 3
painkillers.
6 on either side, and that could have all been what we're calling blue modularity. But that can't work, because there must be one blue modularity on there. Oh...
Yeah, I think Simon is going to do this the hard order.
Oh, no, I see. I do sort of see, actually. You can't have... Yeah. How could you have 2 of what I'm calling blue modularity on this line? I don't think you can.
Yeah, Simon is absolutely going to do this in I think the harder order.
So what do I mean by that? Well, blue modularity is 3, 6, or 9. If I have 2 of 3, 6, or 9 on here, it won't work. Because whatever the other digit is, the mathematics, the sort of remainders don't work. And I mean, I can just see that, but hopefully you can too. I mean, imagine these were 3 and 6, for example. Then obviously this must be 0 mod 3. And if these two
exactly,
Isabella, are both perfectly divisible by 3, then so must that one be. Otherwise, maths doesn't work. So this one definitely doesn't have 3 blue digits on it, and I've just worked out it doesn't have 2 blue digits on it. So it must have exactly 1 blue digit on it. Because it can't have 0, because I can't put 3 blue digits on that modular line. So there is 1 blue digit on here. And does that mean we've got... Does that mean... I'm wondering if I can prove that this is red modularity.
Exactly,
if the
Isabella.
middle digit here was say a 6, then these would be one of each, wouldn't they? Oh no, but I could have... Oh, hang on, no. Because if that one... hang on. Oh, good grief. Right. Okay, this is now getting seriously complicated. I think I've got something here. Right. Right, got it. Okay. It is possible that this is 3 different modularities. For example, if this was 6, that could be a 2-4 pair. If this was 6, this could be a 1-5 pair. 1 has is from the 1-4-7, 5 is from the 2-5-8. So you can see you can have 1 of each modularity, and the mathematics of the line absolutely work. But if we did do that here, then we're going to have a red there, aren't we? We're going to have a red here. So there can only be 1 red on this line, which means
I think he's thinking about this whole part exactly the reverse of how I did.
But then what is this digit? Is the question I want to ask. Because I don't think that can be. Because the version of red that this is going to be is not the top version of red, which is going to be this one. So this is going to be, if this is 8, this could be as high as 5. And if this is 7, this could be as high as 4. That's the biggest this could possibly be. But it's on a zipper that's got 4 digits on it. So this would have to be 5 in that instance. And this would have to be 1, 2, 3, or 4. And I can see that doesn't work. Because what on earth am I putting in that cell now? That cell, remember, is getting duplicated in box 2 It's in one of those cells.
There we go. Okay,
I don't
he
know which
remembered
one.
that, but he didn't actually.
But no, it couldn't be. It couldn't exist. This is so clever, zetamath. I mean, it's quite complicated actually, but it's indisputably beautiful. So in fact, we've worked. Hang on. So now let me just get this clear in my head. So I'm now saying that there cannot only be one red.
Yeah. So Simon is like tying together two different things at once, which is often actually when Simon sort of does things not exactly the way I intended. It's because he sort of does two things at once. If Simon had just written 1, 2, 4, 5 into this cell, thought about none of what's going on in this row at all, and just thought about this cell and what he said about zippers, then he could say, okay, well, this cell can't be anything but 7, 8, or 9. And then Simon could have the rest of these thoughts about this. But Simon's doing all of this together, which is making this one step more complicated, which is why he's making that face as he tries to sort of circle how all of this works together.
Maybe that was the point I should have got to. Maybe that's where I should have started. I should have said, is it possible there's one red on this line? Because I know it would go there, and I know this would break. In fact, it would make it more obvious if I put the options in for that, wouldn't it? So maybe that's the logical order, the more logical order. I should have said, okay, that is not red. There are two reds, therefore, on this line. So this line has no reds on it. And we know it has one blue on it, so it has two yellows on it. And if it has two yellows on it, the yellow is in the middle. This is it's beautiful, isn't it? Why do I think yellow is in the middle? Well, because I can sort of see that when I add a 0 mod 3 number to any other number that isn't 0 mod 3, it will preserve the modularity, the result will preserve the modularity of the number that isn't 0 mod 3. Does that make sense? I mean, or to put it another way, imagine that yellow was from the 147 set, and these were 1 and 4. Then each of those individually has a remainder of 1, and when you sum two remainder 1 numbers together, you're going to get a remainder 2 number, which would mean that the blue would...
For the record, I just want to say, I'm really, really glad I'm not having to explain this out loud to people watching my streams. I have great respect for Simon trying to have the thought and then articulate this particular idea, which is, I think, like, I agree with what he said earlier, and I hope it's true. It might not be true. I hope it's more intuitive than it is easy to spell out in words. But I would have a very difficult time, I think, trying to articulate this in a way that people found coherent.
Which there shouldn't be a blue digit on here. It should be a red digit in that instance. No, it doesn't work. 1 plus 4 is 5, which is from the red set, but we need the blue set to be in there somewhere. So, now I've got double yellow in here. So now this digit is yellow, which is that one. Because I can only have one yellow on this line now. And yellow is not the modularity of red, but it's also not 369 modularity. So this digit is 7 or 8. And that is a 7-8 pair. Because and the reason we know that is we know this can't be as low as 5, don't we? Because if it's 5, this number's destroyed by the fact that this is a 1, 2, 3, 4, 5 quadruple. We can't be 6 because it's not from blue modularity.
It's interesting. So in my mind, because this clue was here before this clue. So in my mind, it had to be this way. I deliberately drew this line here because I saw that it couldn't be 6 because this 1, 2, 4, 5 destroyed every way of making 6. Or sorry, destroyed one of the two ways of making 6, and so you couldn't make 6 both ways. And so his proof that it can't be 6 is completely different than mine, but of course he has more information than I did. But that's very cute to me.
It can't be 9 because it's not from blue modularity. So it is whatever this isn't. It is 7 or 8. But from the alternate modularities.
Also, what he calls yellow, I called red, and what he called red, I called yellow. So translating this in my mind is always tricksy.
Reality. Some of the sentences I say in these videos are so mental. I mean, it's just crazy. So now what does this mean? It must mean something. So now this one is the highest of its mod. So that one.
Sudoku sentences out of context.
Doesn't that have to be 4 or 5 now?
I would love that.
It's the sum of 2 different digits, so it's at least a 3, but we know it's not from the blue modularity. We know it is the smaller, therefore. It's the middly modularity related to yellow. So if yellow is 7, this is 4. If this is 8, this is 5, is what I think we're doing. So these 2 digits are very, very low digits. And one of them is a 3. One of them is a 3 because one of them is of blue modularity. Now.
So glad to hear that, Stephanie. Yeah, there very much is a learning to ask the right questions. Like the right questions to ask in Sudoku puzzles feel so unmotivated until you hear someone ask them enough times. I think that's part of why Simon has been so useful, and Mark, to be clear, to the sort of the growth of the Sudoku community, is sort of hearing them ask the questions makes it easier for then you to ask the questions, which then sort of teaches you this new way of thinking and sort of communication.
Now, what does that mean? I don't know yet. Come on, zetamath. What am I meant to do now?
Color these 2 cells.
The modularity of this one is going to repeat.
So my intended step, I'm not sure if this is exactly how he's going to do it, because this is the step that I know at least several strong solvers have not spotted and have done in some way that was a little bit horrendous. But here's my intended spot here. Where did the 3 yellows go in box 5 is the intended question for me to ask. So these 2 can't be yellow because of the modular line. Okay, one of them can go here. And if you'll recall, I mentioned for a long time this is a length 2 modular line. That was basically just to say at most 1 yellow gets to go on here. And therefore there has to be a yellow here. And therefore by the modular arithmetic stuff that Simon has been saying, there has to be a yellow here, but the only yellow left is the yellow 7, 8. The 2 low yellows are down here. That's how I would say this. Let's see how Simon does it.
Here. But I suppose I should label it, shouldn't I? It is therefore yellow or blue modularity. And now I don't know what to do. So this... Right, so these cells are red and blue modularity. All the yellow modularity has been used up in row 6. So this is all red and blue modularity. I
so relate to Simon's row brain stalling out because I'm thinking about a bunch of other things, trying to remember what row this is on the Sudoku grid.
So if that's red, that's red. And if that's blue, that's blue. And I really don't want it to be this line. I don't know how to think about that. Yeah, I mean there is something there though, isn't there? I mean, if that's a 7, it almost breaks the world. Because if that's a 7, then red's modularity, this would be 8, and red's modularity is 258, so this would be 2 or 5. And if that's 7, that means you couldn't have a 2-5 pair on this line. So that would have to be 1, 6, 3, 4 in some weird order.
He is in the unfortunate situation that we as solvers always find or so often find ourselves in, where he is thinking really far ahead into what will happen in the world that in fact actually does happen. Because his intuition has misled him into believing that this is the world that is going to break. We have all been there. Hey, Mekti, how are you doing?
But if this is 8, this is 7, this is 1, 4, this is...
Oh, absolutely, Earth Computer. I have so many complaints about that. But yeah, and if this were going to be like coordinates, then like, why do we count up this way but then down this way? It's sort of like, it's how we label matrices, but not really. It's there's a lot of strange like, I mean, ultimately I think the fact that mathematicians label the entries in matrices the way they do is a disaster. Not that I go out of my way to fix it, but then we also have the positive and negative diagonal, I think, are screwed up. There's all kinds of very weird things, because like the quote unquote positive diagonal is the one that has negative slope if you actually write down the coordinates. Because like this is 1 1 2 2 3 3 4 4 5 5. This is y equals x, and so that's like the most positive slope line you could possibly have.
5.
But this is really mathematicians' fault more than Sudoku people.
4. And that puts much less pressure on this line. Now. Oh dear, I don't know what to do again. Okay, so this... Sorry, I haven't got anything. I'm sure there's something clever I'm meant to do here, and I'm not. I know I'm not doing it, and I'm feeling a bit daft. Okay, that one is not yellow. That is true, isn't it? Because this digit on this sort of 1 shape is repeating there in terms of modularity. So if this was yellow, that would be yellow, and then I'd have 4 yellow digits in box 6. So that is either blue or red modularity. Which might complete the blue modularity. If these were 6 and 9, that would finish the blue modularity in box 6. So, oh dear, I don't know how to think. I just don't know how to think about this. I'm well aware that you're probably all shouting at me. I feel like shouting at me. I don't understand. It's not going to be how you add up numbers to get to red modularity, is it?
Kind of.
Or is it not? I don't know.
I will say that yellow equals red plus red is one of the only things that was on my sheet of notes I used while setting this.
I know there's a red here. I know there's a red here. I don't know whether there's a red up there. There could be. If there was a red up there, then this line contains no red. So let's think about this. I think I am going to have to think about this. If red was 7, that has a 1 remainder when divided by 3. So 2 digits say those two digits, that add up to a one remainder digit are either going to be themselves a red and a blue, for example, because you could do a 4 and a 3. That would work. Or it's going to be two remainder digits, like 2 and 5. That would work.
Yeah, this is definitely... You can definitely get there from here.
I don't think there are other ways of constructing numbers. If you're adding two different numbers to get a one remainder, that must be right. So, and it must be the same with 8, isn't it? If you've got 8, you're either going to have a remainder, a 0 remainder digit, like a 3 and a 5. So you've got red, you'd have red and blue. Or you're going to have 2 one remainder digits, which is going to be 2 yellows in this case. Right, so this line is either, each pair on the line is either, well, it's not that both of those can't be yellow. So this Angel of the North thing here, that it's not possible both of those are yellow, because that would put too many yellows in box 6. So a maximum of one of those is yellow. Now,
I do think this puzzle is for a very specific audience, Isabel. I don't know that I communicated that super well on the thing.
Actually, I'm not sure. That's one of each. Ah. Oh, zetamath, you are a devious creature. You really are a devious creature. Okay, let's keep going with that. Okay, now how here? So on this stretch, on this domino, I've got it labelled as blue yellow, but only one of them is yellow and one of them is blue. So there is one yellow in there. How many yellows are there in there? And the answer is a maximum of one yellow.
So I commented earlier about how I really wanted this to be a length 3 line and not a length 2 line, because if it were a length 2 line, I'd have to like write a whole extra sentence to the rules of modular lines, which I don't think helps. However, part of me did contemplate, and I'm not actually sure of the answer, whether the telegraphing about thinking about box 5 and the coloring that Simon is doing now, if this didn't have this extra doohickey, it might have been louder that you should think about the coloring in box 5. But I had another, like, devil on my shoulder. I guess I'm implying I have a devil on each shoulder. I had another devil on my shoulder that was arguing, but if this is a length 2 modular line, no one's going to look at it because they're going to assume that it means absolutely nothing until the very end of the puzzle, when it was indeed sort of like central to disambiguating everything at this point in the puzzle. So I was really sort of unsure. And I guess it probably depends solver to solver whether they look at a length 2 line like that squarely set inside of box 5 and say, okay, I should think about box 5, or look at a length 2 modular line and be like, okay, that must have been the last clue added, I shouldn't look at it.
No, because they are consecutive along a modular line. Now imagine there was no yellow in there. If there was no yellow, this would have to be double yellow to get us to 3 yellows in box 5, and we can't have double yellow here because that causes double yellow there and breaks box 6. So there is a yellow on there, definitely, and there is one yellow on here, which means there is one yellow on here, which means this is red or blue. There is one yellow. It's either those two are yellow or it's these two are yellow. And then the other pair is going to be, this is impossible to show, but the other pair is going to be
red, blue. So
red,
like, these are yellow, red, blue.
No, it is, yeah. It's going to be a red and a blue. So if this was red, for example, that would be blue, and vice versa. But I mean, I haven't got a clue.
Yeah, that's what I was really trying to decide, Jennifer. I was really not sure if that was the extra kind. I tried to be extra kind, but I'm not sure. How
we're ever going to show that. So
So I think Simon is going to do this exactly the way I intended. Because now he's
Ah,
got to
so
ask
what
what
does
the
that
yellow
mean?
digit is in box 6.
Um,
Which I have to say,
I would absolutely love to know.
the disambiguating which is 7 and which is 8 by exhausting all the yellow digits that could go on this line except the 7 8 is one of my favorite steps I've put in a puzzle. I was really tickled and happy when I was like test solving and saw that it worked and saw that it was doing that. Like I was very happy.
How I'm meant to. I know there's a blue in there. There's a blue in there. I know there's a yellow in there, don't I? That's true. So I know this is red or blue. Just in terms of the modularity along this line. And I know that that digit is summing with yellow, no, summing to a yellow with this digit. But if that's blue, that would make this yellow. And if that's red, it would make this, oh, make that red. That doesn't, that look, oh, that looks quite tricky. It depends. It depends whether, if yellow was 8, then you could do 1 and 7, couldn't you? That would actually work. But if that's 7, and you're adding 2, I don't think that would work. Because I think one of these would be the red 8, and it wouldn't work then. Because this can't be red 8. It could be red 5 standing by. I don't know what he's doing, making an appearance in the puzzle. Hopefully shooing off Maverick. Okay, these 2 digits, if that's 8, 2, 5 adding up to 7, yeah, okay, and if that's 7, 1, 4 adding up to 5.
Oh, you're so close, Simon. You're right there.
Oh, no, it's fine. It's fine. Oh, you are a crafty man. You are a crafty man, zetamath. Right. Okay, here is the point. This line contains 2 yellows. Now, and this line contains 1 yellow. But the type of yellow that this line contains is the big yellow. Because these are the little yellow. If this is 4, there's a 1 in one of those. If this is 5, there's a 2 in one of those. So big yellow lives on this line. Well, if big yellow was 8, adding up to 7 then, that isn't going to work. So big yellow is 7, adding up to 8. And we've got the modularities now sorted out. That's only taken me...
Good job,
that's the first
Simon.
digit. It's taken me 45 minutes. I'm sorry. Okay, but this is red modularity. So that's 2 or 5 going in one of these 2 cells. Oopsie, didn't mean to do that. I don't know what button that was, but it was a jolly exciting one. Now, this is yellow modularity. So that's a 4 with a 1-3 pair.
I do love that this length 5 dipper ends up being a 4.
That means that this is also a 1-3 pair. Oh, that's a weird deadly pattern on this staple. Oh, okay, but I guess that gets resolved by this modular line somehow.
Yeah, Simon's absolutely right. This would be a deadly pattern if nothing were willing to intrude onto this zipper. In other words, there'd be 2 solutions to the puzzle because you could swap the 1 and 3 and no one could tell you were wrong. But fortunately, in this puzzle, I'd already resolved that cells were going to match because that was happening up in the very beginning, and then I did a lot of crisscrossing of these various lines. So it ultimately ended up being that, like, yeah, I was just committed to doing that anyway, so it didn't offend me so much to do that.
Oh, this is 7 now. So that's 7. This is good. So this is 1. Ah, now 1 is yellow. So that's not... do we know that's not yellow? Yes, we do know that's not yellow. Because there was 1 yellow on here. There was 1 yellow on here. Oh, the other thing I keep doing now is I'm trying to look at this as a modular line, and that's total nonsense. Sorry, not as a modular line, as a zipper line. I was trying to make these two add up to 8, and I was looking at the 2 and the 5, and I was thinking, it doesn't work. That can't be anything.
I did that
but
so
no,
many
it's
times
fine.
for
It's
some
fine.
inexplicable
This is modular.
reason.
So... Sorry,
You have a nice quad available in column 3 that you
trying
commented
to see
earlier.
how this works. So the 7 in this box is now in one of those 2 cells, isn't it? So 7 in box thingy, this box here, is in one of those 2 cells. Here's something. Right, let's go back to this 7. We looked at this before. It now has got a 2 or a 5 in its column. So this domino, for example, is not a 2, nor neither of that is a 2, 5, or that is a 2, 5. So this is filled up with 1s, 6s. 1 and 6 make 7, don't they? And 3 and 4 make 7. And neither of those ones can be a 1, because there's a weird 1-3 pair over here. In fact, that can't be a 3 either. But these can't include 6, because if either of those was a 6, it would have a 1 on the other side. So this is 4, and this is 3. It just seems to have happened by dint of Sudoku. And we've got a 1-6 pair in the other positions.
Don't forget to color.
And, this is good if it's true. Right, I think it's true. Oh, well, 3... Yes, it is true. 3 is the 0. Mod 3 is a blue. It's a blue.
And this cell, 50 minutes into the puzzle, is the first cell you get to actually mark as being definitively blue. And thus able to center mark as 369. Because as I commented earlier, blue is 369. That's like one of the first deductions you make in the puzzle. But there's nowhere to notate it because you don't have a single blue cell anywhere until this step, which was very weird to me.
So this is yellow-red. And where is 3 now in this box? By Sudoku, because it can't repeat on its own modular line so quickly, it's got to be there by Sudoku. So that's 3, and that's 7. And 7 we know is the funny modularity, the yellow modularity. This is now another blue, whoopsie, that's blue modularity, so that should be... So this is a 4, because we've had 1 and 7, and we need a third yellow modularity. This is now red modularity, so that digit is 2 or 5. Don't try and do maths on this. I have to keep trying to add this line up. But if that's 3, that's got to be...
I'm glad I'm not the only one.
A 6 or a 9 along its modular line. And if that's 4, that's got to be 1 or 7 along its modular line. Feels like that should be resolved.
Interesting. I kept feeling very bad about the fact that in my solve path, I used that this couldn't be 7 because if this was 7, this cell would have no value. And it kept looking very look aheady to me. And I sort of figured out that okay, you can pencil mark enough that it's not so bad. But Simon just completely skipped having to do that by placing this 3. So that makes me feel a little bit better about it.
Okay. Now, what should we do next? I don't know. Let's get rid of that 3 there.
I think this cell's blue
4
now.
is over there on this little. It's definitely. Can that be a 4? 1, 3. This would have to be a 1. That would have to be a 3. Maybe, I don't know. That's definitely yellow modularity. These are yellow and blue modularity. I'm not sure whether we're going to have to keep going with the modularity, but we might as well try. What about this 8 then? That's a zipper. It's not 3, 5. It's got to be 2, 6, look. Ooh, can we do that? So it's a 2 and a 6. 5, 8, 9 to put into the rest of row 5. Can we do anything with that? Do we know what that one is? I don't know. We probably do. We know it's the same as this one, don't we? So if that's 5, 8, this would be 2, 5, 8. If that's 9, that has to be 6 then. 7 is in one of those two cells in this column. Or column 9, I should say. Oh,
For what it's worth, my way of thinking about this is actually different than coloring all of box 5. What I thought of in box 5 was, where does 9 go? And pretty cleanly, 9's not going to go in a zipper summing to 8. So I had sort of corner marked 9 in here a little bit earlier.
Dear, I think I'm getting stuck now again. Naughty zetamath, what have you done here? How am I meant to do this? I keep looking at this and I find this very disconcerting as well. Could we do... Oh, I don't know what those are, do I? They have to add up to 7 as well. So they're not 2, 5, so they're 1, 6. Or 3, 4, I'm going to claim. Those two.
Soon you will know.
I don't think I know which they are. I'm puzzled. But we do. Oh gosh, yes, because this is all an anachronism, isn't it? From when I did the original shading. Those two have the same modularity, and these two have the same modularity. So and one of those is 7, which is yellow modularity. So if that's 7, this is 1 or 4. And that would be 3 or 6. And that would be 3, 6 or 9. Wow, I don't know. 9 in this box has to be on this line, doesn't it?
There you go. That'll do it.
So that's useful. That's useful. Yeah. Okay. So just by noting 9 is in here, look. We know that over here there is a blue modularity digit. Now that blue modularity digit is not 3, it's not 9,
cute.
so it is 6, look, and that means I get that digit. That's a 1, and that's a 6. And 1 is yellow modularity, and 6 is blue modularity. Now that can't be 4, because that would have to be a 1-3 pair, and this can be neither of those digits. So that's not 4, this is 4. 4 is yellow modularity digit. And so we've actually done an awful lot of this column. 7 in this. Oh, that was almost beautiful. I thought I've got something really good there. 7 in
is
this
Simon
column.
going to see the awesome thing that I realized you didn't need?
Sudoku. So it's in one of the bottom two places, and that's an X-wing on 7s at the bottom of column.
Oh, Simon's totally going to see it.
6 and column 9. Now, when you get this sort of pattern, you can ask where 7 goes in the other row. So in this row, you can see.
Oh, that's not the cool thing. The thing I thought was really cool that I deliberately worked in here is that this X-wing on 7s actually tells you the coloring of the modular line regardless of which one is 7. It turns out that if you do enough Sudoku, this step is not useful, or this step is not necessary, but I was super happy with it, and
it can't be here.
I was hoping some people at least would use it.
In one of those two positions.
Simon's avoidance of Sudoku will make it more likely that it gets used.
And if you're saying, yes, but that's as useful as a chocolate teapot, I couldn't disagree with you. Oh, Bobbins, I don't know what to do. How do I do
He's really
this,
holding out on not pencil marking the remaining 2 cells in box 5.
I know.
I guess he did say earlier his brain didn't want to think about row 6, so I guess it makes sense.
Hang on. Neither of those is yellow. Ah, that's important. Right. Look at this triple. These, we know that the yellow. Okay, let's actually label this up. I don't know what the colour of that one is, but that's yellow is definitely that one, isn't it? So this is either blue or red. But in this triple, I need a yellow. And the yellow must be there, so that's a 1. And that's going to disambiguate, no 3 in the corner. That's going to disambiguate my my deadly pattern, which is something I've been worried a bit about. So now those are both yellow, but now this digit is yellow. So that has to be 4, I think, because it sees 1 and 7. So this digit is no longer 4, which means that digit is no longer 3, I think. Now, does that take us forward, please? Actually, I have got something as a result of that. But I'm actually just want to look up here for a moment. Let me just think about this. This is one of each. So that digit is either that digit or that digit. If that's 2, it's got to go here. If it's 5, it's got to go there. And then this
Have a good dinner, David.
Would be 2 or 8. Oh golly, I don't know. So how do I do this then? I have not got a clue.
He's going to do it in a very complicated way. Of course he's going to do it in a very complicated way.
I'm meant to spot here. It's not this zipper, is it? So but that digit could be a 1. I suppose that's at least a 5. I don't think that's under pressure, but I'm just going to label it. It's 5, 6, 8, or 9. It's not 6, apparently, due to this 6 pencil mark. So...
probably not 8.
Oh, that's... okay, that's actually useful. I'm going to think a bit more about this cell, because I just got a surprising result. It's at least 5, because this is a 4. So it's 5, 6, 8, 9, but I have got a 6 here. Now it's 5, 8, 9, and that seems to be a triple on 5, 8, 9. But we should think about this digit, shouldn't we? It's either 1... oh, this isn't 8, because that would be a double 4. Can it be 5 there? Maybe, depending on that digit. Oh, this is gorgeous, right. But now, there is a 5 on this zipper, because either that's a 5 or that's a 5, so that's not a 5, because this cell sees both of those.
I will admit I did not intend that.
Now, that could be a 5 if that's a 5. Yes, okay, but we've got this 5, 8, 9 triple, so these squares are 2 and 6, apparently. Now, what that means, I do know what those are. I just have to work it out. Oh, that's big if that's true. 5. 5 and 9 is what these are. So this digit is a 2, and that digit is a 6, and that digit is a 2, because I am allowed to do maths. And 2 is a red digit. 6 is a blue digit. Oh, so those two were the same. Okay. And what? 2, 3, 5, 6 is the digit that's definitely in this top portion here. And those are the same, aren't they? So if this was 5 or 8, this is 5 or 8, and if this is 9, this is 6. So this is either 6, 5, or 8. And you sort of think that must do something. This 6 means oh, that's good. This 6 means these aren't 1 and 6. So these are 4 and 3. In that order. And now the 7 must be sort of diagonally opposite it by modularity along the left-hand tuning fork. So this digit is 6 or 9. Ah! Okay, so we can do that. We can
Don't
do
get
that.
too greedy, Simon. Expecting like more than one digit at a time.
7. This is 6 or 9. And okay, we must know 1 and 8 now have to be in the middle row of this box. 7 is on this tuning fork, not this tuning fork, this zipper line at the top, which is going to make it difficult.
Oh, hey, Sweet Blues. Yeah, I'm still at it. I've been posting some Let's Plays too.
The only way that can be a 7.
Do you prefer asynchronous viewing?
Because this can't be a 1 because of this pencil mark. It would have to go 7, 2. And this would be a 9. And that would be a 9. Ah. I can't put 9 there. You can't put 9 on the wing of a zipper. Yes, I see. Right. So where's 9 in column 3? And the answer is I haven't got a Scooby-Doo. But it's definitely not there. So 9 is in one of those two squares, and now this can't be 7, because the corner digit is definitely not 8, because this would be a 1, and it's definitely not 9, because the 9 is there. So the 7 is in the corner.
It looks so smart when he explains it that way.
Which is yellow. Maybe I could have done that by Sudoku, actually. I'm now seeing I've got loads of 7s everywhere. That's now a 7 by Sudoku. Oh yes, I saw something else about 7s. Oh, am I going to tell you that, or do I? Yeah, I'm going to tell you. I saw this digit couldn't be 7 for a really cool reason. But you see the 7s in the bottom these bottom columns here. They're either arranged like this, or they're arranged like this. Now, if this was 7. This has to be 7's modularity, which was going to be a 1 or a 4, which it can't be. So that is not 7. This is 7, and the 7's go like that. And that's yellow. And I think we have done all the 7's in the puzzle.
I think that is true.
So let's carry on. 1s are in these two positions. This now is a 1. Because it has to have the same modularity as the 7. That's a beautiful step, by the way, zetamath. Now, this column, that digit is definitely not 8, is it? But there's an 8 here. So this is a 1-8 pair. And now this digit, 6 or 9. No. 6 or 9 is blue.
Just for the engagement, Simon should leave the 1-8 unresolved for a long time.
And
It would get comments.
maybe it's this one or maybe it's this one. I haven't... Okay, this can't be a 2-5 pair. So it's either a 4-3 pair, which is going to be in this order, or it's going to be a 1-6 pair.
Yeah, exactly.
Don't tell me that can be in either order.
Said when I planted this, I knew this was a 4. So that was why I put it this way. And then you could sort of figure out, okay, that'll get you the last little bit of oomph you need to make everything unique.
The one would go here, and this would be a 6. 3. So, what does that mean? I don't know. It probably means something. He says somewhat desperately. Oh dear, I'm not sure. No, sorry. I don't think I've got anything cool to tell you about that. Is that it feels like that probably is resolved by some mechanism, some devious mechanic that only zetamath understands at the moment.
It may be, although I'm not confident I'm the only one who understands it.
It's not necessary that one of those is a 1, is it? No, I don't know actually, but I'm noticing 1 in box 7 has to be in those cells. So column 3, what do we need? 2, 5, 8, 9. So that can't be 9. So that is 2, 5, 8. It can't be 8 now because we just put a 1 there. And obviously 8 plus 2 is too big. So this is, right, so that's red. It's 2 or 5, and there's an 8-9 pair in the column, and hopefully that's going to do something for us.
The vicious mechanic of all time, yes, definitely.
Is it, or is it not? There's got to be another red there, doesn't it, in this row? Yeah, it's going to be something. Oh, okay, there's no yellow on here. So is it modularity again?
It's always where is the 9 in column 3, but it's never how is the 9 in column 3. It's true. We really need to look out for our Sudoku digits better.
I mean, the middle digit here, I'm going to claim now, can't be a blue digit. Because if it was a blue digit, the only way the colours would work is if this was a yellow digit, which it can't be. So that has to be a red digit, because it can't be a yellow digit, and I've just proved it can't be a blue digit, so it's a red digit, and that means this is a blue digit to make the maths work. And now this is not. Oh, this is sick. This is absolutely sick. That's a 3 in the corner because it's not a 6, and it has to be blue mentality, and it can't be 9 because you can't add 9 to anything, and that's 3 in the corner. That's 3 in the spotlight, losing its religion. That might be my favourite moment of the whole puzzle, and that is saying something.
I'll try not to be too hurt by that, Simon.
Now, okay, so we now know this is 5 or 8, and we know there's definitely a 5 in one of those 2 cells because there is. So the red modularity. Oh, that's it. I've done it again. Zetamath is just breathtaking. It's breathtaking because once you know this is either 8-5 here or 5-2 and there's a 5 on it, you can... Oh, no, I don't know. Sorry. No, it's a red digit here, isn't it? But I don't... It depends where it goes. If it goes there, it's definitely 8. But if it goes there, it could be 2. Oh, bother. Okay. Okay. 2 is in one of those 3 cells. That seems to be true.
A digit-based murder mystery?
What to do.
That sounds good.
Don't know what to do. Must be something Come on, brain, compute the thing.
Maybe place a few 4s,
Is
just
it this
recreationally.
8-9 pair? Is that doing some damage for me somehow? I'm not sure. It could be. Oh, it could very well be Sudoku, couldn't it? Yes. Where's 4? 4 can't go on the yellow line. Or when I say the yellow line, I mean the line that's already got 2 yellows in those 2 positions. So that is 4. This is 4 now. So Sudoku is coming to our rescue.
It's funny, at least for me, the coloring was
one
useful
here is
in this to
doing some
maintain
damage
throughout, just because of the
using
Sudoku.
those 2 cells by Sudoku as well. Yes, Sudoku is suddenly being helpful.
It is true that Sudoku was not very helpful for a lot of this puzzle.
8 is now in these cells as well. But surely... Do we know something about this column? 5, 6 or 9 into that cell, but I don't think I know which one. How many 4s have I got in there? I have got loads of 4s. I hadn't realised this at all. Yeah, that's it. Where's 4 in box 1? Goes on the line. So that's 4, that's 3.
I do know that was sneaky of me to
that's
use the
3
digit
by
that is
Sudoku.
given by Sudoku.
I think all the 3s might now be done. All the 4s are done. So somehow or other... Oh, I see. Yeah. Okay, a different way of... Because that's double red, there is a red there. I mean, it's a red and a blue. I don't know, but this can't be red, can it? Oh, that's it. That's lovely. Good grief. Yeah, because this is double red and there's got to be a red in one of those 2 positions. That can't be 2 or 8. So all of the reds in this box are there. And now that has to be a red digit, which means it has to be 5. That's 5, that's 9, that's 6, that's 9, and we're off and running again. It's a spectacularly clever puzzle, this. I mean, it just is. Now, oh, that's now a 6 by Sudoku, so that's a 9. 9 is a blue digit, so there's a 6 in one of these as our special friend.
Our special friend 6.
Okay, and 5 is a red digit, and 9 is a blue digit.
Oh,
and now, I see, look, we can use the modularity along this line. So the
this would
5
get me
must
so
go with
bad.
it.
I would absolutely, in solving this puzzle, if I was solving this by myself, fill in those 2, fill in the colors, and then be stuck for an hour not noticing that I could fill in these 2 colors. That would absolutely happen to me.
To preserve modularity
I'd hate for that
at
to
the
happen to
appropriate
Simon.
moment. And then this is going to be a 6. And now, it looks like that's a 6 by Sudoku. That might be wrong, but seems to be correct, doesn't it? So 6 is blue. 6 goes in one of those. Oh, this is good. 6 goes in one of these 2 positions. Now look, there's a little X-wing there, which means 6 must be in one of those 2, and it seems to have to be here, and 6 is the blue, so this is the red, and then that's the red by preserving of modularity rules. This is therefore 5 and 8, and we don't know the order. Do we really not? You naughty puzzle, that's extraordinary. Okay, but it does... Well,
the amount that this grid resisted becoming unique was really quite a thing, I have to say.
It gets us the 9, I suppose. Maybe that's the point it does. Oh, that's unbelievable. Okay, so that didn't work. Oh, but the 9, I see. The 9 gets... Oh, this is big. So that gets us a 5. That does the 5 and the 8. The 5 means this is a 1. So that means this is a 1, look.
There were just a lot of pairs floating around that there were not sort of natural ways to disambiguate from the way it sort of opened up. So like the last, like all the little length 3 zippers sort of are there to basically turn everything into a functional...
This is... where's 5 in the box? It's there. So that's got to be a 2. this has got to be an 8-9 pair. 2 and 5 are both red. And I don't know where we go now, but I am at least feeling more confident that I might be able to get through the puzzle. I haven't put 2, 8, and 9 into the... That's a very doable digit, isn't it? That's definitely a 2. So we've got an 8-9 pair for the rest of column 9, an 8-9 pair in the row. So that's 2 or 5 and seems to have to be 5. So that's 5, that's 2, 5 is red. This column needs
3
6
had it
and
coming.
8.
No jury would convict.
Surely resolvable, but can't see how. I really can't see how, actually. Maybe we try row 7? Is that 2, 8, 9? So that's 2 or 9. And that's 8 or 9. So this is an 8-9 pair. Oh, I see. I haven't put 1 into this column, so I should do that. 1 is yellow.
Do we have 8 ones? I think
This
we have 8
digit
ones.
is
Although the
5,
one in box
8,
3
or
is
9.
dangerously
it's not 5. It's 8
uncolored.
or 9 then. I'm actually going to just double check that. I'm not sure I trust that deduction. 5, I think it's right, because there must be 5 on here. So this is an 8-9 pair, and this is 5-2 actually, which is not really what I thought was going to happen. Although I now see I could have got that from Sudoku, so I've gone the most roundabout way of getting that. This is... Oh, the 8 now has to go there in the bottom row. So that's 8, that's 6. Which means that's 6. 6s obviously are blue.
Famously.
Reds are not blue. This digit here is 8 or 9. I've got a horrible feeling. I've got 8, 9 deadly patterns all over the place. I really hope that's not true. No, it's okay. It's resolved by this 8, I think. So 9, 8, 9, 9, 8.
That is definitely one of the 8s or 9s that resolved it.
8, 9, 9, 8, 2, 5. 2 and 5 looks good, doesn't it? That's red. 9s, wherever they occur, are blue. 8's always red. 1's always yellow. 2 and 8 in the middle here. And there we go. What a brilliant puzzle. What a brilliant puzzle. That was mad. Absolutely crazy stuff. I really liked those being double red at the start and me being able to deduce that that was red. And then it was fascinating. I think I did this a bit backwards. I should have thought about the left-hand line first. But there was some very cool arithmetic going on in row 6. And I really liked the fact I could realise that that had to not be too low because of this digit. You can see... Oh, is it correct, actually? Yes, it is. That's good. That's a relief. Wonderful. Zetamath, as always. Thank you very much for setting such beautiful, beautiful Sudoku puzzles. I do appreciate it. Let me know in the comments how you guys got on. I enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.
It was a great solve by Simon. It really did basically nail down my path pretty much exactly through all of the non-Sudoku parts of the puzzle, we'll say. And he even correctly intuited after he did the thing in row 6 that, oh, this would have felt cleaner if I did it in the other order, which I appreciated. Yeah, I hope you enjoyed that, and I hope I provided some amount of insight here. Yeah, I often think, Colin, that for me personally, I think if I get to this point in the puzzle and my solution is wrong, I think I'd just be happier if no one told me. But I guess Simon doesn't have the benefit of there being any universe where he posts this video and he's wrong and no one tells him. So I guess it makes sense that he clicks the button. But I know a lot of people are very concerned about like having answer check work and these various things. And it's like, what if it just always told me I was right? What if it just had ChatGPT tell me how smart and uniquely intelligent I am or something like that, rather than tell me that my solution is wrong? That might be nicer. Uh, Maybe they could do that for the crosswords too. That would be nice. If it just told me I always guessed the right vowel for the random name that I'd never heard of, that would be nice. Uh, all right. Well, thank you everyone for hanging out. I'm happy to answer any questions if anyone has them or whatever. I should mention, I suppose, also that I stream myself solving puzzles like this a couple days a week, and sometimes I solve my old puzzles and comment about them. Although I solve like my puzzles from like 3 or 4 years ago, so the commentary is much less fresh, but it's more like a like, oh, I wouldn't do that now, or oh, that is kind of cool, or whatever. It varies puzzle to puzzle how enthralled I am. But also, I have been doing, like Cracking the Cryptic, my own playthrough of Blueprints, as well as a playthrough of Lingo. Those are ongoing. And I have got some other games coming up soon. Also, for newer folks to puzzles, I have been doing a series where 3 days a week I post a puzzle at an introductory level. And so I do Sudoku variants, but I also do a lot of pencil puzzles. So if I find there isn't a lot of nice avenues by which for people to get into pencil puzzles like Yajlin or whatever. Like they don't usually do them on Cracking the Cryptic, and when they do, they tend to do ones that are quite difficult to understand. So uh, so anyway, I've been trying to do that. Do give those a look if those sound interesting, and let me know. Let me know if those. I just started that Invitation to Puzzles series, so I'm curious how it lands for you. If you enjoy them, do let me know if you have recommendations. Also, let me know about that. And yeah, he definitely would have been much faster for the puzzle if he just left the example in. It was totally random that this happened to exactly match, but what can you do? I guess there's only so many length 5 zippers. But still seems quite unlikely that I happen to pick the one that. And then, of course, like he could have filled it in on any of the length 5 zippers in the grid, and he filled it in on the one that it was the one that matched the example. Uh, oh yes, you might learn a lot about triples. But yeah, I do recommend it. It is a lovely puzzle. Yeah, the first of the Invitation to Puzzles was by Belsita in chat, and it is one of my favorite sort of intro to Sudoku puzzles because it gives you a lot of practice with using the various sort of mechanics that you sort of figure out of like pointing things and these sorts of things. So I would recommend giving that a try. All right. Well, huge thank you to everyone for hanging out. I hope to see various folks around the screen. Do give it a subscribe if you have not. And do please like the video. If you're watching this later, give a comment. I always enjoy hearing from folks. Usually in these videos, I hear like a third way to think about something that I said how I thought about and Simon said how he thought about. I always like seeing those if someone had some other way to make a deduction or something like that. I always find that interesting to see. All right, but that's going to be all for now. So huge thank you for watching, and I'll see you all next time. Bye for now.